do one more example. Example number 2. Copper 2 oxide reacts with carbon to make solid copper and carbon dioxide. We got to write a balanced equation. Copper 2, Roman numeral. What does that mean?
That's the charge.
Charge! Cu plus 2. Oxide is O negative 2 with carbon. So we're going to have CuO plus carbon to make solid copper.
Cu.
Cu.
Later.
Plus,
that was dumb.
Oh, good, yeah.
Yeah.
Plus
Don't ever let me do that
carbon
again.
dioxide. I won't.
Okay.
That's it.
Okay.
Is that balanced?
So what do we...
No, not
balanced.
I've got an oxygen problem.
Yeah.
So I'm going to put a 2 here to get 2 oxygens because of the CO2. And I'm going to put a 2 in front of the copper.
There we go.
So now what do I know? All right, I have carbon dioxide. I know I have 34.5
Milliliters. That's a volume.
That's a volume. So let's put a V there.
Okay.
And actually, you know what I'm going to do right away?
Let's just make it liters.
0.0345 liters. Divide by 1,000 in my head. My pressure is 655 torr. Oh,
let's make that change too.
We can't change it yet, Mr. Sands, because it's collected over water.
Oh!
If it's collected over water, we must refer to the
table.
The water vapor pressure table.
I bet you have that.
What to find? Oh, I bet I could find. There it is.
What temperature were we
I don't know.
No,
What temperature were we
got
at?
so excited.
I know. 32 Celsius.
Celsius.
So at 32 Celsius, the pressure is 35.
35.6.
We'll call that 36 because I think we've got it to...
36.
So we'll subtract 36, and that equals, Mr. Sands?
619.
619 torr. And while you're at it, divide that by 760, and we'll get our ATMs.
0.814.
0.814. All right, PV in, we don't know.
We don't know. We'll get
but
that from...
we do know our temperature. That was 32 degrees Celsius plus 273 is 305, right? Yeah.
Yes.
305.
No, wait.
Yeah, that's right. 305 Kelvin.
Yes.
So we have everything to do the ideal gas law.
Right. So last time we did Stoich first, and then we did PV equals nRT.
So, yeah, let's talk about what you're going to do. Once you get in, we're going to solve for in just a minute. You're going to use stoichiometry, and you're going to, actually, we didn't actually put this here, but you're trying to find the grams of copper 2 oxide. You're going to convert to the grams of copper oxide using stoichiometry.
So PV equals nRT first, then stoichiometry.
Yeah. So
last time we did stoichiometry, and then PV equals nRT.
So let's do our PV and RT.
All right, let's do it.
P is 0.814. I'm not going to put the units in there. V is 0.0345 equals N. We don't know that. R, of course, 0.0821. Notice I'm just plugging in my numbers, and my temperature is 305. When you get N is what, Mr. Sands?
1.12 times 10 to the negative third.
And that's moles of oxygen.
Carbon dioxide.
Carbon dioxide, I knew that. Okay. So this is my starting number I'm going to put in my stoichiometry. So I'm going to say 1.12 times 10 to the minus third moles of CO2. Now I want to go from moles of one substance to grams of another. So the moles of the CO2. Now I do have I'll use my mole to mole ratio. So I'll say 1 mole of CO2. Now that 1 comes from the 1 in the balanced equation right here to 2 moles of carbon copper oxide, copper 2 oxide. And now I'm going to use the molar mass of copper oxide, so 1 mole of CuO to so many grams of CuO.
79.5.
And that's 79.5. So we're going to, moles of CO2 cancel, moles of copper oxide cancel, and we take 79 to 2, pretty small number.
No, it's a
couple of grams? No way, Mr.
Got it. No, I must have done something wrong. 79.5
times 2
times 2
times 1.12 e negative 3
times 2. I must have hit the divided by sign. There we go. 0.178.
0.178 grams of CuO.
There we go.
So notice what we did. We did PV equals nRT, solve for N, and then we did, that was this whole step right here, and then we took the N and did a conversion down here and converted the moles of carbon dioxide to the grams of copper 2 oxide. So you're going to do lots of problems like this, and this is going to become like second nature. We just wanted to give you 2 quick examples so that you can know how to do it. You may need to watch this several times.
Well, hopefully stoichiometry is already second nature to you.
Yes. Okay.
Whoops.
I think I hit the button.
I think you did.
That. Okay. So that's it, and we will see you in class. Bye-bye. See ya.
Don't break any flasks.
Yes.